знакомый, чем со мной, и он всем известен в этой аудитории. Здесь у нас собралось сколько сейчас? 8 человек, которые будут вас слушать, но в виде видеотрансляции увидят и услышат гораздо больше людей. Так что, Василий, займи место, пожалуйста. Начинаем.
Начинаем тогда.
Так, ну что, надо показать на аудиторию? Да? First of all, Mariusz, let me show you the audience here.
Oh, yeah.
The people who are gathered, despite this Friday 13, despite this 13 events, they are gathered to see you, like online. So here are our audience. I guess later on I'm gonna introduce you to each and everyone. And last not least, I guess, and blah blah blah. So about the agenda, I guess. How much time do you need, approximately?
Well, you know, to talk about my research, all the time in the world.
Okay.
But we can start with 40 minutes.
40 minutes. 40 minutes is okay. So,
if it's okay for you.
First your talk and then questions. Is it okay
Right.
for you?
Perfect.
Or maybe you can be interrupted in some way?
Yes, please. If you have any questions during my talk, do not hesitate to interrupt me immediately.
Okay. So first, please show us a couple of slides, just to make sure that we can see them okay. Please start the presentation. I mean, you're gonna show us some slides, aren't you?
And how can I do this on Skype?
Okay. Okay. I guess you can show us your desktop. There is a possibility.
Yeah, and where I do this? Anybody? Windows 10? I'm not usually working on the system, so I really don't know.
There must be some button, some not hidden button. Show the desktop.
Let me have a look. What can I do? What can I do?
Когда мы будем смотреть либо презентацию, либо его, да?
Да, конечно.
There is a kind of function to switch from your video to your desktop. There must be kind of button or function in Skype.
In Skype?
Yeah, in Skype.
All right, let's have a look then.
Or you can switch, okay, you can open your presentation at your computer and you can switch Alt.
Oh yeah, wait. How about that?
Okay.
Wait. Seems that I have something.
Yeah.
Something happened?
Yeah.
Yeah. And I guess you can open widescreen, yeah, if you don't mind. I just to make it visible, more visible. It's visible, but to make it more visible, please open it widescreen, please.
How about
Okay,
now?
yeah, very nice. Yeah.
Great. I feel proficient in Skype now. So, let me start.
Mariusz, sorry, one more thing.
Yep.
Please shift my video to the right, because now
Right.
it's occupied. Yeah, something like this. Yeah. To the right. Yeah. Право.
It's okay?
Something like that. Okay.
Great.
Yeah.
So first of all, thank you for this invitation. I'm greatly honored by this possibility to give a talk at your seminar. Also, I'm very happy to see that I'm definitely well beyond or above the median age of the participants, which is always a good sign. And I probably should, first of all, establish something like credentials, why I have the courage to talk at the logical seminar. As you can clearly see, my talk is not that heavily related to what we traditionally conceive as logic. Well, I used to be a logician. I did some work in proof theory and in logic of questions. Vasily is familiar with that. But then I kind of took seriously the claim made a couple of years ago by Johan van Bentum from University of Amsterdam that it's okay and good and interesting to do logic for itself, but it's even better and more okay and more interesting if your logical tools can be applied to something in the outside world. So this is exactly what I'm going to talk about today, about formal modeling, which is applications of formal logical tools to human reasoning. And this will be a story of a hunter-gatherer, mostly because after a short start explaining what do I mean by formal modeling of human reasoning, I'd like to show you at least one example of such modeling in depth and just mention a couple of others. So the first question is, if we start to talk about hunting and gathering, what are these hunting grounds? And if we try to make a very short history of logic and in relation to the study of human reasoning, or psychology of reasoning even, well, we basically would start with the quotation or the gist of the organon by you exactly know who, that logic is the instrument by means of which we come to know anything. So, and that was basically the state of the art for like more than 2000 years, that logic as a formal study of arguments, of reasoning processes, of information processing, stood in very close and very natural relation to real human processes. Even if, like in the mid-19th century, Augustus de Morgan or George Boole just very briefly mentioned that connection at the very first pages of their handbooks in contemporary logic, and all the rest of these handbooks was full of just formal languages, they still mentioned it, that this is exactly the reason and the purpose for which logic is organized and performed. Then, of course, we had this anti-psychologistic term towards the end of 19th century, and we landed in a situation which is very well captured by this second quotation by McNamara. I like it very much, that people who basically do research on very similar areas, logicians and psychologists, started to consider themselves, each other, I should say, as alien, as people who do work on similar topics, but from a completely different and wrong perspective. And only recently, we are basically coming back to this Aristotelian idea that if you have well-developed formal tools, then, of course, you may develop them for themselves, for their own purpose, and that's okay. But it's even more interesting if you can apply these tools to something in the external world. The important change is that for Aristotle, this external world meant obviously mostly human activity. For us, well, we have this completely new, from this ancient perspective, completely new possibility of developing our tools and applying them into the area of artificial intelligence, which is probably even more alluring for logicians than just, you know, whatever biological subjects perform. But in order to do that, in order to apply this well-developed formal tools, well-developed mostly because we abandoned this psychological perspective of in the late 19th century and turned to mathematics. That should be stated quite clearly, that this mathematical turn gave us enormous advances in logical research. What exactly is the subject we are hunting for? What exactly is to gather? And it used to be quite of common knowledge that logic is good for establishing what is normatively correct in reasoning. Logic is good in establishing norms. From my perspective, it's slightly different. What is most interesting in looking for applications of formal tools, real human reasoning processes, is the opposite of normative correctness, is the error. Because this is exactly this, the errors which offers us a window into how humans solve problems. From a perspective of artificial intelligence, it would be probably different. But from a perspective of real human reasoning processes, this is exactly this. If I can identify ways in which human err in his or her reasoning, this tells me something about how the information is processed. Because if all I have access to is something that is correct from a normative point of view, then, well, what I know is probably that my subjects are well educated in formal methods, in logic, in programming, and stuff like that. And this is not a real problem solving. But errors offers this window which allows us to say something about what people really do, and also which allows us to apply our very sophisticated formal tools to model this activity. One trouble is that if you try to identify what exactly can count as an error in reasoning, well, you have a number of possibilities. I listed here just a few. You can start with something that is very simple and very traditional, like you err in reasoning when your conclusion doesn't follow from your premises. And that was, well, kind of obvious criterion in the times of Aristotle. And criterion for what does it mean to follow was quite clear. Now, not exactly, because of these huge developments in formalized or mathematical logic we witnessed in the last 100 and something years. Your premises may be not sufficiently justified. You may misinterpret the premises. This is a ubiquitous problem in research in which syllogistic reasoning is involved, categorical sentences. The subjects misinterpret particular sentences very often. Your reasoning is not goal-directed. You misconstructed the task, which means that you solved different tasks that you were asked to. And very nice examples of that are in the writings of, in the characterization of these experiments done by Wuria in 1930s, for example. And so on, so on, so on, so on. More and more sophisticated concepts of errors can be defined here. But if you look at all of them, what should be kind of apparent is that with our formal tools, so sophisticated, so different, so well developed, there is more logics at the moment than the stars the sky. The trouble is that you can find basically a formal tool for any occasion. You can model any way of processing information by using logical tools. Developments in philosophical logic mostly offer that from the 30s on, basically. So there is a legitimate question whether there are any errors in reasoning, because the question about errors begs, obviously, the question about the norm. What does it mean to define normative correctness for reasoning? What does it mean to define normative rules? What does it mean that reasoning should be this or that? Well, obviously, contextual. On the other hand, we may ask about what people really do. We may ask about reasoning as it is actually practiced. And then we search for something that describes activity. But we may also aim at something in between. And this is the level which I'm interested in. We may aim at something that is prescriptive. We may aim at answering the question, well, we are computationally limited. Our rationality is bounded. So, what is the best use to which we can put our reasoning abilities, taking into account these limitations? And that's this prescriptive level. Obviously, we don't have all the time in the world. We don't have all the computational power in the world. We don't have enough of all these resources to perform reasoning as it should be, ideal, to solve problems, not taking into account constraints of time and other limited resources. But it's not that much interesting to just describe what we do. The question is, what can we do better than we do at the moment? And who hunts and who gathers? Well, this prescriptive, normative, and descriptive perspective are interesting for obviously different areas. A cognitive psychologist would be interested in descriptive and prescriptive perspective. Just cognitive scientists would be interested in all three perspectives. Logician, probably mostly normative and prescriptive perspective. And in all this interest, this common element is this middle ground, this prescriptive perspective, the question about what is the best use which we can put our reasoning abilities, taking into account our limited abilities. And what we exactly can achieve with this model. This probably, we can start with overly optimistic stance, this Panglossian stance that claims basically that human reasoning is actually normatively correct and the errors are just slips. We can go to the very bottom, which is a result of a couple of decades of research in psychology of reasoning, which says that people basically don't reason at all. People just solve problems, or reason only when they are forced to in very artificial contexts, like formal schooling, for example, to something in between apologist and Mickiewicz stance, which says that well, we don't follow normative rules because no longer know what normative rules are. But certainly there are some regularities in our solving, and these regularities can be accounted for, and these regularities can be evaluated, because our problem solving, our reasoning, can be, well, better or worse. And now the whole idea is to identify what does it mean for our reasoning to be better than worse. And this is in fact the gist of this practical or cognitive or psychological, if you prefer, the names are different, terminology, which started something like 20 or 30 years ago, which consists in going back to the idea of the role which logic has to play which seemingly Aristotle had in mind. The logic is a tool which can be applied to our information processing activities. However, this term, practical, cognitive, or whatever, slightly expands this perspective. As Van Benten nicely puts it, logic acquires a new task of systematically keeping track of changing representations of information. It's not just the episodes of reasoning we are interested in. It's something more comprehensive, more complex. And also, new fields open for logic. Because our formal tools apparently can be applied not only to what they traditionally were applied to, I mean sentences to which we can, or propositions to which we can ascribe truth values, this or that, but we can do this on many new representations, including those which are not exactly linguistic. Not linguistic forms of reasoning, problem solving, also can be analyzed in terms of our refined logic formulas. So to some extent, logic becomes capable of modeling actual cognitive activity of real-life agents and becomes capable of informing us about ways in which these cognitive activities can be improved. To some extent, of course, because still actual cognitive activity of real-life agents is something that is hellishly complex. So this trend, let's say, in logic without cognitive or practical term, it basically claims that first, it is not the case that logic has nothing to do with how we think, and this is in direct contradiction with anti-psychologistic claims by Frege and Husserl, and also contests the claim that this distinction between descriptive and normative account, which also Frege and Husserl made, is disjoint and exhaustive, because we this third perspective, this prescriptive. So the question, of course, is whether logic is still relevant to this endeavor, whether logic is still relevant to research on real human reasoning activities, whether it should be confined to its own Platonic world and the real activity should be left for, like psychologists, my colleague from Institute of Psychology. Well, that's the view which Evans nicely tapped on old paradigm in the psychology of reasoning, in which consisted basically of study of deduction, construed as the beacon of normative correctness, and was restricted to classical cases. So Bayes and selection task, for example, and all the consequences which stem from interpretations of Bayes and selection task, which basically shows that in abstract context people can't reason with conditionals in a way which is normatively prescribed by classical logic. Results of this study showed that, well, as normative yardstick of correctness of reasoning, deduction is useless because people don't aim to do what this normative yardstick prescribes, and it also shows, the results of this experiment also shows that this is not the right yardstick to be applied in all the circumstances. So it's not universal. It's not that universal as we used to think about deduction for quite some time. Versus the new one, the new paradigm, in which reasoning, judgment, decision-making are all viewed as involving similar processes of transforming information, in which, in order to account for regularities in this process, we need to recognize pragmatic and, well, inductive or ampliative, to be precise, nature of human reason. So, under this view, deduction is basically viewed as something that well, still is useful, because, well, funnily enough, ability to reason deductively is a very good predictor of general intelligence, for example, which is still nice. But this ability is viewed as more like a strategic level concept, as a form of reasoning in which people engage, were instructed or forced to, like I mentioned, formal schooling, for example, in which in order to engage, you need to exhibit a high level of reasoning ability. Not all of us are that fluent in playing chess or solving Sudoku, for example. And these are paradigmatic examples in which human reasoning, deductive reasoning, is well involved. I'm not claiming that in playing chess, of course, deduction is all there is important to them, but it's certainly crucial. So what do we hunt for and what do we gather? Well, all the three levels: norms, descriptions, and prescriptions. And what I wanted to show you in the second part of this talk is just one example of such hunting and gathering, an example of reasoning, modeling reasoning, which from a point of view of deductive logic is, or old paradigm, I should say, is difficult to grasp. It's abductive reasoning. We have a number of studies of deductive reasoning, of deduction, in many different contexts. We have lots of studies of deductive reasoning in abstract contents involving whatever, classical categorical sentences, conditionals. These are two most popular tools to do research on the subject. We have a lot of studies in which we are concerned with how our information processing is biased by the content of premises, for example. This is mostly done on classical categorical sentences. But the reason for that is that studying deduction is kind of easy, because we have this normative concept of what does it mean for deductive reasoning to be correct. In case of abductive reasoning, not so much. And this is what I wanted to show you. The remaining ones, well, if time permits, but I don't. So, abductive reasoning, the trouble with abductive reasoning is that we don't have a precise definition of what this kind of reasoning is, in stark contrast to deduction. The most famous formulation is by Charles Sanders Peirce, and this is exactly what you have here. The background is Greek and Latin edition of Analytica Priora, in which for the first time the term deduction is used, exactly here, beginning of 25th chapter of Analytica Priora. The surprising fact is observed. If A were true, then the fact wouldn't be surprising at all, so there is a reason to suspect that A is true. We may construe this reasoning in many different ways. In a very broad one, it would be a reasoning in which we make sense of surprising or ambiguous phenomena. And under such a broad account, or basically any interpretative activity, verbal, non-verbal behavior, investigation, scientific, forensic, clinical diagnosing, or empathy, even modeling of information processing, can be construed as examples of abductive reasoning. In more narrow view, abduction would consist in explanatory activity, let's say. But I like very much this other interpretation. So now the question is, how people do abduction, how people do reason abductively. In case of deductive reasoning, that's simple. You have a couple of paradigms in which you can research for ways people perform deduction. You can offer them premises and ask what follows. You can offer them the whole reason and ask whether it is correct, which of course should be worded without any technical terms. There are ways. In case of abductive reasoning, which is definitely more ubiquitous activity than deductive reasoning in our everyday life, if you think about all situations in which we need to interpret something surprising, ambiguous, or just difficult to understand, in all these cases we have abduction. And we, at the moment, are even unable to offer a precise definition of the phenomenon. If you try to perform research on that, then obviously first you need to decide a couple of issues. First issue would be whether you are interested only in, let me go back to this formulation, whether you are interested only in this, only in your abductive hypothesis or possible explanation of your surprising phenomenon, or you are interested in the whole reasoning process. Are you interested on analogy to deduction? Are you interested in which conclusion follows from the premises? Or are you interested in how this reasoning is performed? It of course depends on what goal you have in mind, but definitely the process is more interesting and would be more informative about abilities than just a product. Is it just a generation or evaluation of hypotheses? Again, let's go back to the schema. Are we interested just in producing as many hypotheses, as many A's as possible, or are we interested in producing only the best of them, most probable, the most plausible? Well, again, if we are to keep anything close to reality, we are interested in this second. We are not crazy generators of hypotheses. We are practical people who want to solve problems. We don't have all the time in the world to decide what our interlocutor had in mind while talking to us. So we need to find hypotheses which fit best to data. Is it just about explanation, or maybe something more? Is it just the explanatory relation between A and C which is possible, or maybe some other? Are we just interested in facts, or explanations, like hypotheses, can be more complex? Rules or theories, if we face a surprising phenomena in any area of science, are we interested in just finding explanations in terms of facts? Not usually. Usually we are interested in anything which counts for data. If you think about some paradigmatic example like oxygen theory developed by Lavoisier. That was exactly the case in which the abductive hypothesis was a whole theory, not just a fact. A theory which superseded the old ITER paradigm. Is there any creativity involved? That's a tricky one. If you think, for example, about clinical diagnosis, if you think about what clinical diagnosis consists in, this is exactly the scheme. Surprising fact is observed. So there are some symptoms. And we try to find the cause. We try to find the sickness or disease. So what we observed may be standard. Like our patient has a flu. No problem in that. But if you remember at least one single episode of TV series House MD, then you know that clinical diagnosis can be much more creative. And how to select information, that's simple. How to create new information, oh, that's much more difficult. And we have ways to model. So, what's the difference in these studies between abductive reasoning and deductive reasoning? Well, the basic difference is that in case of deductive reasoning, we do have decent answer to the first question, the substantialist question. What is X? We have a precise, no definition. What does it mean for reasoning to be deductively correct? In case of abductive reasoning, not so much. If you look again at these two formulations by Peirce and by Taggart and Shelley, what should be clear, and Critica also, what should be clear is that in case of abduction, we start with this. We start with the instrumentalist question. How abductive reasoning is used. And what we try to model is exactly this. It's not normatively correct concept of something, like a piece of abduction. It's just the use to which we put abductive reasoning. So basically, the way in which information is transformed in abductive reasoning. And this exactly fits into this practical or cognitive term in logic. In case of abduction, I very much like to think about it as compound reasoning, which consists of both generation and evaluation of hypotheses. And as a result, I can see no reason to claim that abduction cannot subsume other forms of reasoning. In particular, if you think about evaluation of hypotheses, testing of theories, for example, well, this is a paradigmatic example of positive testing and negative testing. Positive testing, example of ampliative reasoning. Negative testing, example of deductive reasoning. So, under this account, abduction subsumes other types of reasoning as well. One trouble is that although we have lots of tools for research on deduction, we have virtually none for research on abductive reasoning. Because it is complex. Because it's not exactly known how to capture it, and it's not exactly known what exactly to capture. And these which are existing, this is the shortest dismissal ever. They are either normative or over-artificial, and they say nothing about what people need. So we carved our own, and what I want to show you is the way they were carved, let's say. Basically, we used setting which is as close to natural language processing as possible. We use games. We use puzzles, which our subjects are supposed to solve by asking questions. That's another nice property of abductive reasoning. You solve abductive problems by asking questions. You may ask them explicitly or not, doesn't matter, but you need to ask them. So we make our subjects to ask them explicitly, limiting a little bit the range of possible questions to be asked, just not to be overwhelmed with data. So as you see, we use here only yes/no question, but it's enough to order to get a very interesting data. If you're interested in how this data look like, all is available at this website. We made a linguistic corpus out of that. That was the convergent case, our first study in which we led our participants to correct solution. In these types of puzzle, there is something like the correct solution at the time. Then we went slightly more open, and in our still ongoing study, we don't have correct solution. We don't have default solution. Subjects are just supposed to come up with explanation what happened in the presented enigmatic situation in a way which they feel is the best. They are playing the role of an investigator for a local media outlet, and they are supposed to find an explanation for some phenomenon. And now to the models. Luckily, what we found can be exemplified on a much simpler example. If you are familiar with the 20 questions game, that would be very handy. In a 20 questions game, you have somebody who is supposed to invent a category. Could be whatever object, usually it's animal, could be whatever. And you have a number of questionnaires which are supposed, in 20 questions, simple yes no questions only, to identify what the proposer had in mind. So here you have a very simple example. It's by the way, it's a great game if you have a long car ride before you and you're like 5 years old, is slightly bored of the ride. So here you have a very simple example of such a game. Animal, yeah, animal, yes, and so on and so on. And in both these setups, mind, place, and find out, subjects are supposed to perform currently cognitive activities very similar to this which are here. They are just done on slightly more refined material. I'll show you that in a moment. So what did we excavate from this data? Two operations. Two, in a Boolean sense, I mean, George Boole, mid-19th century. Boolean operations of mind, sifting, fun. What people do while solving these types of problems? Well, if you look at the initial part of this gameplay, is it animal? Is it mammal? Is it rodent? Is it a rat? Well, this is basically funneling. The questions are supposed to narrow down the searcher. And then, if you look at the question, is it a rat? Is it a guinea pig? Is it a hamster? Well, there is no narrowing down. There is like slicing of some established area of search. Rodent and then pet. Yeah? So this is exactly this. Sifting, the second operation, sifting of unnecessary information, and funneling in order to narrow down your search area. So there is a number of ways in which these operations can be performed, and they can be defined in very simple terms, as you can see, using well, some semantics which goes beneath the level of truth value. You can go some version of truth model theoretical semantics. You can use, that's probably the best solution, some situational semantics. You can use truth maker semantics. This basically doesn't matter. Definitions are very similar. The idea is to show in what these regularities performed by the subjects consist in. And all these types, joint sifting, no common core sifting, something left behind, are types of sifting we find in the data. And there are also others which we can define well, because they are logically possible. Yeah? That's more or less like a situation with model logic, when you start with some intuition, and then when you define your notions, it occurs that, oh well, I can define a number, huge number, of other concepts of modalities, which I hadn't defined earlier, but they are just missing. So we have this sifting of different types. We have funneling, which can be defined also very precisely in terms of topics or in terms of questions, whatever you prefer. However you prefer to model your information processing, and we are able to, well, show how this accounts for data. Again, I'm showing you just a very simple example of 20 questions game, because the others are, they will require a slightly bigger screen, let's say. But this works exactly like this. It's just that in this example, what is funneled and sifted are obviously sets of objects, like animals, mammals, and so on. In case of tasks in which you are to explain an enigmatic situation, what is sifted, funneled, can be modeled as sifting or funneling of sets also, but sets of situations. That's why situational semantics or truth maker semantics come into play. And there is a huge range of applicability. The operations are very simple, very basic. We do this all the time, and we've done this probably at the beginning of our problem solving. But first, they account very well for our data. Obviously, we can do better. we can do more fine-grained analysis of all that stuff, and this is ongoing. And also, we can do more, like for example, the list of open problems here. Explicit divisibility, other operations like elaboration of information, which is crucial in our search for explanatory information. Evaluation of reasoning ability, because with this model you can also try to account for what does it mean to perform ampliative reasoning better than your fellow human beings, and so there is a number of other possible examples. I just want to show you one more, and very briefly. What is also nice is that you can go with all these insights or intuitions or early stage development formal tools to the area which offers you a much more of computational power. You can go to artificial neural networks, for example, and try to model human solutions with these computational powerful tools, and also try to play with them, try to tweak them in a sense, in such a way as to see what should be done in order to solve your prescriptive problem. Like what can be done better, take into account computational limitations. That's a very simple structure of connectionist system. In fact, it's a hybrid system. It starts with symbolic representation of knowledge, logic program, and then translates it into neural network. Then there is learning, then translation, and then you have the answer to the question, how I need to modify my initial knowledge base in order for certain information to be accommodated. Or what minimal information is needed in order to justify this or that conclusion. That would be a computational account on objective reason. That's a subject of PhD of Andrzej Gaj. So the answer to the question, where do our models come from, is basically threefold. They may come out of nowhere, out of the blue, like normative correctness concept in reasoning question, the concept of hypothetic implication, for example. They may be excavated, they may be just regularities which encounter in subjects problem solving, like sifting and funneling, and may be cooked in a row, like these applications of ingenious, in fact, applications of proof methods which were needed in order to set up artificial neural networks, which will do exactly what we wanted to do. What is crucial in all this is that in this research, practicality matters in the sense that if we go with our tasks to the people, if we ask the subject to solve our tasks, it more often than not appears that this leads exactly, Stenning and Lambalden claimed, to clarification of what they are trying to do. It's often that we are so overwhelmed with our normative ideas that we can't see other possibilities of interpretations of information we want the subjects to process, of other ways of processing information. And when we pay attention to that, a plethora of new data opens, a plethora of new areas for research, a plethora of possibilities of applications of our formal work. And the basic lesson from that, for me, is formulated here, the second and the third point. If you want to account for human reasoning processes, then you need to go Poznań, like Francis Bacon. You need to work as a bee, as an ant which just gathers, not as a spider which just works with his or her mind. You need to gather and transform. And that's when where the data become very handy. And also, if you are serious about your formal models to be about something really like human reasoning, then you can't escape some triangulation. You need to use formal methods to model. You need to quantitative approach to find regularities in data. You need to qualitative studies. You need to do qualitative studies in order to account for all the peculiarities which are basically the salt of all this research. People do err, and they sometimes err systematically and regularly across different subjects, sometimes not. And all this can be accounted for by our formal methods. And obviously, that's the reason we are doing it. This is just so much fun. Thank you very much.
Questions? Thank you very much, Mariusz.
My pleasure.
Any question?
В докладе был затронут широкий круг вопросов, конечно. Тут необходимо время для осмысления. Вот мы надеемся, я как главный редактор журнала «Логические исследования», надеюсь, мы опубликуем статью по материалам этого онлайн-семинара, чтобы все желающие, присутствующие могли более внимательно и глубоко проанализировать высказанные идеи. Вот. Сейчас у меня несколько вопросов меня затронуло. Ну, во-первых, тут как бы в этом докладе, этот доклад связан со старой вот такой вот мыслью, что логика связана с рассуждениями. Что такое логика на самом деле? И вот тут по этому вопросу, как есть разные точки. То, что говоришь. Да, ну, видишь, тоже да.
I'm trying to do my best, but if you just could speak a little bit slower, it would be easier for me.
В докладе был затронут широкий круг вопросов, и один очень старый вопрос, что такое логика и как она связана с тем, как мы рассуждаем. И вот есть точка зрения, что она, психологи и так далее, и в том числе некоторые логики, что она действительно анализирует то, как мы рассуждаем. Но есть точка зрения, что, в общем-то, логика имеет к естественным рассуждениям человеческим весьма далекое отношение. Да, и что логика на самом деле это инструмент обоснования нашего знания. Да, в какой-то степени она соотносится с тем, как мы рассуждаем, но природа ее другая, цель другая, она для другого создана. Но все равно, в любом случае, очень подробная презентация доклада, она дает возможность лучше постичь, скажем, высказанные идеи, и, возможно, через некоторое время сформулировать какие-то возражения, или, наоборот, мысли в развитии высказанных идей. Вот так я могу сейчас только выступить относительно того, что услышал.
But your Raj is saying that your presentation is full of information and we need some time, yes, you know,
надеюсь, что я понял вопрос, конечно. So let me, well, it's not exactly a question, but let me go back to this. Yes, you are exactly right that it used to be quite clear what logic is up to a certain point. This Aristotelian account was valid, well, more or less till the mid of 19th century. Still, Bull, De Morgan, and others obeyed by this idea of logic as a tool for telling us something about the ways in which we process information. The basic laws of reason, for example, in De Morgan's witness to that. Later on, well, it also was quite clear what logic is, although it was something completely different after Frege and Husserl, obviously. And now we are in trouble because, well, for a couple of reasons. Let's say, for example, let's have a look at this. So we have here artificial neural networks. And we use them to model certain kind of reasoning, regularities in the reasoning. Is it logic? Is it computer science? Is it what exactly? No purity here at all. Well, on the other hand, if you think about, you know, the reception which rather coldly welcomed Tarski's development in theory of truth in the 30s, or philosophical logic in general, this may change. But what is important for me is this, that you have, or we have, different areas which are different disciplines, scientific disciplines, equipped with different tools which work on a similar area, like psychology of reasoning, like logic, like artificial intelligence. And with the exception of psychology, of course, both logic and artificial intelligence can be developed on themselves. At the moment, they don't need any input from the real world, let's say, in order to fruitfully develop themselves. It's not necessary, not at all. But it's first, as Van Benton claimed, it's much more fun if we can apply our tools to something in the real world. And second, these real world phenomena are and always been great engine for inspiration. If you think about development, in model logic, for example, well, it started with Aristotelian model syllogisms, basically, with more or less formal or systematic, let's say, account, not necessarily symbolic, but let's say formal, account on what does it mean that something is necessary or possible. And then it turned out that if we define this in precise terms, well, there a whole new universe opens in front of us, because well, we can play with the concepts. And if we equip this area of research with decent semantics, like cryptic semantics, for example, even more rich universe opens, in which we basically can account for any linguistic representations with a decent tool for searching for some systematicity in usage, this linguistic representation. So it's no longer clear what logic is. That's completely true. But or what is the object of logic, let's say. It's more or less like what I said about abduction. Abduction is what we do by reason in a certain way. Maybe it's the same. Maybe it's the same with logic. If we search for regularities, if we apply what we have found in this search for regularities in human reasoning, then we do logic. And also, please notice this last quotation from Van Benton on this page. It's from like 11 years. It's like 11 years old. 11 years old, Johann van Benton was brave enough just to claim that there is a logician and there is a psychologist, and they work next door. And how do they communicate? Well, they call each other. Now, we are working together. That's a kind of progress. We are working together and with very impressive results. One trouble for me is that in order to capture this prescriptive level of what is the best use to which we can put our reasoning abilities, we need to somehow find a common level, common language for what is normative and what is descriptive. So we have the data, we have the models, and we need to somehow make them close enough in such a way that they can talk to each other. That's difficult, because normative models, of course, are precise, and descriptive data are rich, and this does not always go hand in hand, but sometimes it happens. Sorry, that was a rather long remark.
Pytanie, proszę Państwa, pytanie.
На английском, да?
Ну, или тогда медленнее.
It's a question for clarification. Thanks for the talk. You were telling us about abduction, but did mention Gabay and Wood's conception, which is quite popular right now and which is original and certainly quite formalized. Why?
Sorry, could you repeat the question?
You didn't
I understood it's about Gabay and Wood's.
Gabay and Wood's conception of abduction. Their approach is quite formalized and quite popular at the moment, and I'm just wondering why you didn't say something.
Why I didn't mention it?
Yes, exactly.
For quite a simple reason, in fact. Well, all these studies I was talking about in the first part fit into the concept of abductive reasoning Gabay and Wood's outline in this 2005 book. In particular, they fit into this third model they define, because, well, basically we can distinguish between in research and abduction, we can distinguish between three types of models. The first one is in which abduction is construed as explanatory reasoning, and the links between evidence and hypothesis is to be deductive. That's very simple models. Computational accounts, you can find them in, like Atosha Aliseda, PhD from 1997. Then you have slightly more refined view, which is exemplified by Paul Taggart, in which abduction is explanatory and not necessarily deductive, an account in which the links between hypothesis and evidence are the links of coherence. And then you have Gabay and Wood, who claim that, well, basically, let's go back to the concept of Aristotle, to the concept of apagogic reasoning, and there need not to be explanatory links, they need not to be deductive links, basically anything goes which performs certain tasks to which we put abductive reasoning. But their model is, in fact, it's not a model of reasoning. It doesn't answer the question what people do while devising abductive hypothesis. The model starts with the idea that we identify the target. Then we somehow identify the information which needs to be gathered in order to hit the target. Then we create some hypothesis. Then we have this presumptive acceptance, if you may say, about something like presumptive acceptance, and so on, so on, so on. So this is a description of stages of reasoning. But, well, okay. How do we come up with a hypothesis to be accepted? That's the gist of abductive reasoning. So when we represent this kind of reasoning, like here, we use Gabay and Wood's model in frame. We start with identification of target and so on, so on, so on. So these are the steps. But we go slightly deeper in trying to answer the question, what exactly cognitive activity is performed in order to identify prospective hypothesis, and what are the regularities by which these hypotheses are found. So that would be the answer why I didn't relate here that explicitly to Gabay and Wood's model. But just to justify the stance, in all the papers we publish about that, there is a proper reference.
Any question?
Thank you for your talk. I would like to ask about unconscious reasoning and modeling. For example, Stenning and Lambergen tried to make a model of autistic reasoning in a false belief task and other kind of task. And in my opinion, it could lead us back to Helmholtz's idea that logic is something like innate ability of our reason. And you know that, for example, Wilhelm Wundt criticized this view, and he named it logicism. It's not Frege's logicism. And what do you think about this? How is it possible to model unconscious patterns in reasoning? Thank you.
That's a very good question, because it touches upon probably the most difficult problem we face when we are that generous, as Stenning and von Lambergen are, in ascribing to humans reasoning ability. In the great book, Human Reasoning and Cognitive Science, they claim at some point that, in fact, we do have logics in the mind. Not exactly that we can identify these logics, not exactly that we can explicitly say how do we solve certain problems, but we can do them. And we kind of fluently switch between different logics, let's say, in different tasks. The trouble is that under such view, you may claim, as I started with, that there is no such thing as error in reasoning, because for each information processing episode, you can find some regularity. You can find a logic, a formal system for every letter, basically. Which model logic is correct? Well, each of them is correct as long as they are sound, complete, and whatever conditions we would like to impose on formal systems. So what does it mean that we model regularities in human reasoning? How can we judge which reasoning is better and which is less better? That's a kind of problem we face. On the other hand, that's kind of very fresh example we encountered in very recent research in which we used classical categorical sentences. Basically there are two problems. The first one is interpretation of particular sentences, especially affirmative particular. Some A's are B's. right? You need to express them in a proper way in order to induce logical interpretation. Like at least some A's are B's. It turned out in our previous research that the best outcome for inducing this logical interpretation is to express these sentences like certainly at least some A's are B's. And we had tasks in which people need to put negation in front. And what is the interpretation of negation in front of such a sentence? Well, if you have three-valued logic, if you have three options to choose from, true, false can be stated. Well, if it's not true, then it's either false or can be stated. Not really, because our subjects interpreted negated sentences of such a form as false. Basically, all of them. And so what? Well, and that's wrong. And you can find a very nice formal model for that, because this is exactly what is prescribed by Jan Łukasiewicz extensional interpretation of model functors. It's exactly this. How do I know that this is wrong? Because there is another factor that needs to be taken into account. If you think, for example, about deductive ability, if you want to test deductive ability of your subject by categorical sentences, what do? You formulate some syllogism or polysyllogism or something like that, and then you ask the subjects to provide conclusion or evaluate conclusion or evaluate the whole schema, something like this. But doing this, you evaluate, in fact, two abilities at once, in confounding them. The second ability is exactly what you wanted to address, the deductive ability. But the first is the ability to interpret the categorical sentences the way they should be interpreted. And now, if you think again about affirmative particulars, you can interpret the sentence, some A or B's, in a logical or pragmatical flavor. At least some A's or B's, or only some A's. And your conclusion will be evaluated differently under different interpretation. But if you are consistent, if your subject is consistent in this interpretation, well, this is exactly capturing the deductive ability, right? Only this, not the interpretation. So, from my perspective, the trouble is that we humans, are very good in identifying regularities in our information process. The only trouble is that to determine which of these regularities is better than the others in certain contexts, you need some criteria. And this criteria, seems to me, should be related to goal-directedness of reason. One trouble, again, the third trouble probably, is that goal-directedness usually is expressed in terms of rationality. And this is a very vague concept. And at the moment, that's my core problem. I have a lot of data, I have a lot of models. I can show that some of them are more correct than the others from a point of view of certain assumed normativities. But in order to order these normativities into some kind of hierarchy, which is better, which is not, you need something more. So thank you for that question. That's excellent.
Pytanie, proszę Państwa. Pytanie było, proszę. Ну все, тогда нет вопросов. Well, Mariusz, I guess I'm not having a question at all, the real question or whatever. Just please, thank you. Just please get back to the slide number 12, to the 12th slide. I guess it's 12, with the quotation from Pierce. Yeah, and here we are teaching students that this line, this long line, is a substitution for hands. But is it a new fashion just to write down both the long line and write down the word hands? Is it a new fashion? It's a kind of remark, you know, just because the long line stands
you got
for...
me. Now I'm surprised. Well, in fact, no. Of course, there were no hands in pearls. I guess I put this line here in order to stress one important point in this Christian model, which is basically each part of this formulation can be questioned. Each part is this or that, well, maybe not controversial, but subject to different interpretation. Like, what does it mean that something is surprising? What does it mean that something is a matter of course? What are links between A and C? So what does it mean that if A, then C would be something? And also, what does it mean that the conclusion follows in any sense from these premises? So this line here is used here I guess, to stress the fact that this is reasoning, that this is some decent sense of justification for the conclusion by the premises. But yeah, you are right, it's kind of redundant because hands will do the work as well as the line. So I could get rid of that. That's true.
No, personally, I totally agree with others in saying that definitely we need more time to think about the things, like to scrutinize them. And anyway, we're going to have this opportunity because let me kindly remind you about the continuation of our collaboration. We are seeking for a kind of text, not presentation, but kind of text. And I guess we're going to publish it in Russian or in English?
In English.
We're going to publish it both. We hope, we are looking forward to having it both in Russian and English. I guess with regards to Russian, I'm going to definitely help you. Well, so... Okay, so... Any... Proszę Państwa, Jarosław. You are the only one who can ask pytanie in Polish, as far as I know, among us. No?
Polski nie jest nasze państwo.
No dobrze, dobrze. Okay, I guess, proszę Państwa, or proszę Pana for a nice presentation. Let's continue our collaboration.
Thank you very much. I will be more than happy to, being able to tell about all this stuff in more detail on any occasion, in any circumstances. Yeah. Thank you very much for having me at your seminar. That was a real pleasure.
Thank you too for agreeing. Thank you too. Do widzenia, do pobaczenia.
See you. Thanks.
Okay. Хорошо.
Так, выключай.
Коллеги, кому нужна презентация, сейчас прямо отправлю.
Да.
Есть вот эта презентация.
Есть. Там 76 слайдов.
Ну там разберетесь уж. Да. Он мне все сказал. Так, прям так выключать? Или надо выйти из своего скайпа?
Я выключу.
Давай. Проектор тогда я выключаю. Так, стоп, подождите. У многих есть случаев есть дела на каше, да?
Сектор сейчас.
Сектор, да. Сейчас я по секунду тогда, ладно?
Ангелина, есть дела?
Да,
я тоже делаю.
версия этого.
Что ж такое?
Подожди.
Wine какая-то есть. Это что? Давайте я вам сейчас отправлю.
Давайте, да, с большим удовольствием.
Сейчас он прислал, я думаю, что...
Так. Вот system, вот system shutdown.
Так я не знаю, как выключаться.
Shutdown.
Вот они, вот он занимался логикой, потому что это у них в Познане школа такая, может слышать, да, логикой вопросов занимается. Теоретическая логика. Анджей Вишневский.
Выключить. Подержать. Все, слава Богу.
Да.
Все. Нужно это выключить тоже. Так.
Но ты же русский немного, да, понимаешь?
Он его изучал, сколько ему? Где-то к 50. Значит, он застал то время, когда русский был обязательным в школе. Поэтому он понимает еще тогда, я помню.
Потому что он много тем затронул на самом деле, и поэтому невозможно даже как-то что-то возразить или что. Лучше бы какую-то одну более глубоко разобрал, и тогда так.
А я вот хотела вам на похожую тему статью посылать, но в итоге эпистемологию послали. Там пропало, по-моему, навсегда.
Да, я не знаю. Я если сложно. Там, не знаю, кто-то будет еще мусор.
Так, Вася, давайте сектор, я сейчас это отнесу.
Давайте, помочь что-то, мы ее уносим.
Это все остается здесь, все остается. Сектор,
да,
общаться
идем
дальше. Идите в сектор, общаться, я сейчас закрываю.
Конечно, так. А другое дело, что она же наука такая располагает. Видишь, описательно. Вот говори. Кто сказал, говори.
Спасибо.
Она с вами, да? Все,
да.
хорошо. Если что, пишите все.
Мне будет, так сказать, более